Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 8 from the Mechanics M1 June 2022 International A-Level Edexcel paper. This is the last question on the paper, and this question is about vectors, position vectors, velocity vectors. And it starts off by telling us that in this question, I and J are horizontal unit vectors directed due east and due north, respectively, and position vectors are given relative to a fixed origin O. Okay, so when they say something is going a certain number of, like its velocity, for example, is 15I, that means it's going 15 units due east. Okay, 15 units due east per second. That's what it means. 15 meters in this case, due east per second. All right, so that's what it basically means. I and J. If it's J, it's talking about going north. If it's a combination, we can say it's a certain number of I, a certain number of J. It's going to be going in that certain direction. So that's what I and J is about. And the position vectors are given relative to an origin, which is called O. All right, now, so it says two boats, P and Q, are moving with constant velocities. The velocity of P is 15I meters per second. So I'll write that as VP equals 15I. Now, I like to write things as column vectors. So 15I means 15, horizontally, and 0 vertically. Okay, in this case, 15 to the east and 0 to the north, we can say. And the velocity of Q is 20I minus 20J. So the velocity of Q is 20 east and minus 20, so that means south. 20 east and 20 south. Okay, 20 east and 20 south. That's what that means. So let's find the direction in which Q is traveling, giving your answer as a bearing. Okay, so I'm going to represent Q in a diagram. Let's say Q starts from this point over here. Okay, now if you want to deal with bearings, if you want to give the direction as a bearing, then we have to draw a north line. Okay, so there's the north line. So from this point, it's going 20 east, okay, and 20 south, 20I minus 20J. So it's going to go a certain distance in this direction. Okay, so this 20I and then minus 20J. So the same distance, but south, right? So this line will represent the vector that it's traveling. This line represents its actual movement. Okay, so the direction it's going in is going to be in this direction over here. Okay, we want to represent that direction as a bearing. So that's the direction it's going in. That's the velocity of Q. That's the direction it's moving in. As a bearing, the bearing is always measured from the north line. So we've got to find the angle measured from the north line clockwise. It's always clockwise. So this is the angle that we're looking for. Okay, the bearing that we're looking for is this angle over here. Okay, and this angle is made up of this, which is a right angle, because this is east, 20 east, and then 20 south. So that's a right angle. And what we need to do is to find what this angle in here is. This angle, let me call it theta. Okay, we need to find what the angle theta is in this right angle triangle. This is a right angle triangle because that's east and that's south. They meet at right angles. So if I can find what this angle here, theta, is, I can add it to 90 and I've got my bearing. So what we need to do is to find the angle theta. So we know that this is 20 and this is 20. 20I minus 20J. So this makes this an isosceles triangle. And if this is an isosceles triangle, then this angle is also theta. Therefore, these three angles add up to 180. So both thetas must be 90 degrees in total. That means theta is 45 degrees. Okay, just by the fact that it's isosceles. So we know that theta is 45 degrees. Okay, therefore we can say the bearing is 90 plus 45, which is 135 degrees. And there's our answer. Now, if you're not sure about this, we could even use trigonometry to find theta. We can say we have the opposite and we have the adjacent. This is a right angle triangle. So we can say the tangent of theta is 20 over 20. And when you work that out, it's going to give you 45 degrees. Inverse tan of 20 over 20, inverse tan of 1 is 45 degrees. That's what your calculator will give you anyway. So you can work it out using trigonometry if you wish to, but geometry is easier here because this is an isosceles triangle. And we know the base angles of an isosceles triangle are equal. So these two must both add up to 90, and they're both the same. So it's 90 divided by 2, which is 45. Okay, so there's the answer to part A, the direction which Q is traveling in as a bearing. So I'll just make it clear which is my answer. So the bearing, okay, is 135 degrees. Oops, degrees. Okay, that's the bearing. Okay, that's the direction of Q. Direction of Q as a bearing is 135 degrees. There is our final answer. Okay, this was just our steps here. It's not our final answer. Okay, that was our step to show what theta was. So there's the bearing, 135 degrees. And that concludes question A. Now, it says the boats are modeled as particles. At time t equals 0, P is at the origin and Q is at the point with position vector 200j. Okay, 200j. Let's move that up there. All right. So at time t equals 0, P is at the origin and Q is at the point with position vector 200j. At time t seconds, the position vector of P is given by P meters, and the position vector of Q is given by this vector Q meters. Show that the vector from P to Q is 5ti plus 200 minus 20tj meters. Okay, so we already know the velocity of P and the velocity of Q in the first part of the question, and they told us the velocity of P was 15i, so that's 15, 0 as a column vector, and the velocity of Q was 20i minus 20j, so as a column vector it's like that. Now we know that the position vector of any point, of any object that's moving at a constant velocity, is given by its position at the initial start, when you start, when time equals 0, plus the velocity it's moving at times the time. Okay, that will give us its position vector for any time that we want during its journey. All right, so if we consider P, we know that its initial position is 0, 0. It's at the origin. Time equals 0, P is at the origin. So that's its position relative to the origin. So R0 means the position of the object when time was 0. And we know that its velocity is given by 20 for P, 15, 0, sorry. That's for P, 15, 0. So we can say that the position vector for P, for any time t, is going to be 0 plus 15, we can say 0, 0 plus 15, 0 t. Okay, which we can say is basically 15 t and 0. Write it like that. And we know that for Q, its initial position is, as they told us here, its initial position is 200j. Its initial position is 200j. So that means 0i and 200j, like this. That's the position when time equals 0. And we know also that its velocity, okay, so this is the velocity of P. The velocity of Q is given by 20 minus 20, as we learned in the first part of the question. So we can say that the position vector of Q is given by its original position when time was 0, which is 0, 200, plus, and then we got the velocity vector, which is 20 and minus 20 times the time. And that will give you 20t and 200 minus 20t as a vector, if you write it in this form. All right, so that's 0 plus 20t, that's 20t, 200 minus 20 times t, 200 minus 20t. That's the position vector of Q. So this is the position vector of P. So this is the vector P, basically. We can call that the vector P and the vector Q. Okay, because they've told us the position vector of P is given by this vector. So I don't have to write RP. I can actually write this as P and Q, because that's what they're defined as, the position vector of P and Q at any time t. So this is the vector P and the vector Q as defined in the question as what they are. And that's P and that's Q. All right. So we've got to find the vector from P to Q. Okay. So just say this is the origin O. Let's say this is P and let's say this is Q. All right. So what we've got here now, what we have here, we have the position vector of P. Let me just do that without this arrow there. Okay. So we got the position vector of P, and we got the position vector of Q. That's what we just found. What we found here is, this is the position vector of P, the position vector of Q. Those are the vectors I've just found here. This and this. Okay. What we have to find is the vector from P to Q. We've got to find the vector from P to Q, which is the vector from there to there. That's what we have to find. Okay. This is the vector from P to Q. Okay, that's what we have to find. So if we think about it, if I want to go from P to Q, I've got to go minus P plus Q. Minus P plus Q. All right, I'm going to go from there to there, minus P plus Q. The opposite of the direction of P plus the vector Q. That's what I have to do. So you can think of that as the vector Q minus the vector P. Q minus P. So that's the vector from P to Q, sorry. All right, so now I've got to do, so I now know that the vector from P to Q is equal to Q minus P. All right, so it's going to be these two vectors subtracted. So it's 20t and 200 minus 20t. Take away 15t, 0. So if I work that out, then I can say the vector from P to Q is equal to, that's 5t and 200 minus 20t, which is equal to, in terms of I and j, we can say 5ti plus 200 minus 20tj, and that's what we had to show. Okay, and then just put this other bracket to show, just to put the unit, the whole thing is in meters. Okay, so 5ti plus 200 minus 20tj, and that's exactly what we've shown here. And there's the answer to part B. Okay, now for part C. Find the bearing of P from Q when t equals 10. So I know the vector that tells us how to get from P to Q, which is 5ti and 200 minus 20tj. I like to write them as column vectors, as I said. So that's the vector taking us from P to Q. All right, so we got to find the bearing of P from Q when t equals 10. So first, let's find out the vector. Well, actually, what we could do here, if you want to, if P to Q is 5t and 200 minus 20t, okay, and we want to find the bearing of P from Q, then we can think about it as finding the vector from Q to P, and then the direction of that. So Q to P would be just the minus of this, the opposite direction of this. So it's going to be negative 5t, and it's going to be 20t minus 200. Okay, that's going to be the I component, that's going to be the J component. You just find the negative of this, and that's going to give you from Q to P. And when t equals 10, then the vector Q to P is going to be minus 50 over, that's 200 minus 200. Okay, that's going to be 20 times 10, which is 200 minus 10, which is 0. So it's minus 50, 0 is the vector from Q to P. So if we were to put Q here, all right, this was Q, then P is going to be minus 50i, basically, which is in this direction. So P is going to be somewhere over here. Okay, so that's going to be P. So the vector from Q to P will be this vector here. That's the vector from Q to P. And we want to find the bearing of P from Q. So we have to, we're at Q, all right, P from Q. So we're at Q, so we draw the north line on Q. And we have to find the angle that takes us from the north line clockwise until we're facing P. Well, obviously, if this is, you know, minus 50, 0, that means this is 90 degrees, because that means that's due west of, P is due west of Q. So the bearing is going to be 270. So we can say the bearing of P from Q is equal to 270 degrees. Simple as that. Okay, so there's the answer to part C. And then part D says, find the distance between P and Q when Q is northeast of P. So this is the vector that takes us from P to Q. So again, I like to write them as column vectors. So this is 5t in the I direction and 200 minus 220t in the J direction. So we've got to find the distance between P and Q when Q is northeast of P. So let's say P is here at a particular time. So there's a point where P is at this point here. Now, when Q is northeast of P, now northeast, that's like northeast, it's going to be somewhere up here, but it's going to be up there in such a way that if it's due northeast, okay, if it's exactly northeast, all right, then if we were to draw the north line here, okay, then it means on a bearing of 45 degrees. That has to be 45 degrees. Due northeast means exactly between north and east. Okay, northeast of P, that means the bearing of Q from P. Okay, when Q is northeast, the bearing of Q from P is 45 degrees. So we know that in this case, the bearing of Q from P is 45 degrees when it's northeast. Okay, that's what northeast means. Exactly between north and east. That's the north line. So if that's the case, then if we think about this vector from P to Q, if we consider the vector from P to Q, then this distance and this distance must be the same. Okay, I haven't drawn it so well because let me make it a bit more realistic. So these distances look the same. Okay, so because if it's northeast, then this angle is 45 degrees. So this angle is 45 degrees, and this, of course, is 90 degrees, and that's 45 degrees. So we know that these two lengths must be the same. Okay, so I'm going to call this length K, and therefore this length must also be K. They're both in the same, they're the same direction, the same length. Okay, because this has to be isosceles for that to be 45 degrees. All right, so I can say the vector from P to Q can be represented by a certain amount east and the same amount north, KK. Okay, that's what I can say there. And I know that P to Q is given by this vector. So I can say 5t, 200 minus 20t, has to be such that the two components of the vectors must be equal to each other. The same length as each other. Okay, so what I can therefore say now is that means that I can equate these two because they're both equal to K. So I can say 5t is equal to 200 minus 20t. When I solve that for t, I will have found the time at which they are, due, where Q is due is northeast of P, and then after that, I can then use that time to find the distance between them. So let's first find the time. So I'm going to add 20 to both sides. So I'll have 25t equals 200. Divide both sides by 25. So I have 200 divided by 25, which is 8. So it's 8 seconds when they're going to be, when Q is due, is northeast of P. Okay. So therefore I can find what the vector from P to Q is. Okay. When t equals 8, P to Q is going to be 5 times 8 over 200 minus 20 times 8. Okay, and what should happen, if I'm correct, is that they should be both the same number because we know that they're going to be represented by this vector. That length and that length are the same. So 5 times 8 is 40. 200 minus 160 is also 40. So we know that kind of makes us rest assured that we've done the right thing because they have to be the same. So I know that K is 40 now. Right, so this is 40, this is 40. So now we are asked to find the distance between P and Q. So we can say the magnitude of the vector from P to Q will be its distance. Okay, the distance is the magnitude of the, position, the vector between P and Q. All right, so now we're going to take the square root of 40 squared plus 40 squared, and that will give us the magnitude of P to Q, which will be the distance between P and Q when Q is northeast of P. So that's what we have to find now. Okay, so we're going to do 40 squared, square root of 40 squared plus 40 squared. Okay, so that gives us 40 times root 2, 40 times root 2. That's the exact form, but you can round it to 3SF, that's fine. That gives you 56.568, 56.568 continues. So 3SF, that will be 56.6 meters. That's the distance between P and Q when, so we can say the distance between P and Q when Q is northeast of P is equal to 56.6 meters. Okay, so there's the answer, distance between P and Q, not plus Q. Okay, so there's the answer to part D. All right, now if the question had said north, for example, suppose it says northwest. Okay, if it was northwest, it would be in this direction. So you would say that basically this is going to be minus K and plus K. So you have minus K and plus K. So these would basically, they would be negative of each other. So you would say 5t is equal to, or you could say negative 5t equals 200 minus 20t. Okay, you just have to write them as negative versions of each other. So one of them would you have to put a minus sign in front of it and then solve that equation, and it will give you the time when they're northeast. Same if it was south, southeast. Okay, if it's southeast, they will both have the same sign because one will be, they'll be negative and that also be negative. So they'll be both equal to the same thing again. So they'll be equal to each other. And if it was southwest, it would be the same where they're both opposite signs. So you have to think about if it says northeast, or if it's anywhere along this line, northeast, okay, or southwest, okay, then you know you're gonna have K, and you're going to have minus K and minus K. So basically the two components will be the same as each other. And if it's northwest, okay, or southeast like this, then they'll both have different signs. Okay, they'll both have different signs because this will be K and minus K, and in this case it's minus K and K. So you have to just equate them to each other, but one of them would be negative. All right, so you change the sign of one of them. Doesn't matter which one, and then you'll get the answer. So that's how you have to think about this type of question. It's not that difficult. A lot of students get confused by it, but it's pretty simple. All right, now for part E. It says find the times when P and Q are 200 meters apart. So again, this is the vector from P to Q, which is given by 5t in the I direction and 200 minus 20t in the J direction. So when are they 200 meters apart? When the magnitude between P and Q is equal to 200. Okay, so what's the magnitude between P and Q? Well, the magnitude of a vector is given by squaring the I component and adding to that the square of the J component. So you have 5t all squared and 200 minus 20t all squared, and I know that that's equal to the square of 200. Okay, so this squared plus that squared is going to give me 200 squared. All right, that's the magnitude of this vector. That's what the distance is going to be. So, you know, I could write the square root of this equals 200, but I know that I have to square both sides anyway, so I'll end up with this. Okay, it's like you've got, this is your 5t, and this is your, this from P to Q, and say this is your, 200 minus 20t. Okay, that's P and Q. So that's the length, say 5t, and that's 200 minus 20t. I know that this is a right angle triangle, okay? And this is the magnitude. So I know this squared plus that squared equals that squared. That's what I'm doing. So this squared, that squared plus that squared gives me the same as that squared by Pythagoras. Now let's solve this equation. We can expand the brackets. We have 25t squared plus, this is going to be 200 squared, which is 200. So you're going to have 2 times 2 and then 4 zeros. It's 20,000. Then you're going to multiply these together. You have negative 4. Okay, you double it. So actually you multiply them together and then you multiply by 2. So it's going to be 2 times this. So 2 times 2 times 2 is 8. And then you're going to have 3 zeros. That's 8,000t. Okay, so 200 times minus 20 is 4,000, is minus 4,000 times the 2 is minus 8,000. Then you square this last term, so it will be positive. 20 squared is 400, and that's the t squared, equals 200 squared, which is going to be 4 and 4 zeros. And that's 40,000, right? Square that, you get 40,000. Okay. So now, actually, this is going to be also 40,000. My bad. 200 squared is not 200 squared. You're going to do 2 times 2, which is 4. Okay, 4, and then you're going to have 4 zeros. So that's a mistake there. All right, now we can try to bring everything on one side. Now we have 25t squared, okay, plus 400t squared, which is 425t squared. You've got minus 8000t, minus 8000t. And if you try to bring these numbers together, they're both 40,000, they give you 0, so you can say equals 0. And to solve this equation, we can take t as common, because it says find the time, so there's more than one time. T, and you got 425 times t minus 8,000 equals 0. So we got t equals 0, or you can say t equals 8,000 over 425. So that means t equals, so we take 8,000, divide it by 425, and we get 320 over 17. Let's write that as a decimal. That gives us 18.823. 18.823 goes on. So t equals 18.8 seconds and t equals 0 seconds. So they said find the time. So t equals 0 seconds. Let's see if that makes sense. T equals 0 seconds. We're finding the times when they're 200 meters apart. When t equals 0, this will be 0 and this will be 200. That's right. The time equals 0 seconds. The vector from P to Q was 0 to 100, which means they are 200 meters apart when time is 0. So that makes sense. That's good. And then that's the other time when they will be 200 meters apart, 18.8 seconds after they start their journeys. Okay, so there's the answer to part E. And that concludes our question, and it concludes the paper M1, which we've gone through now from June 2022. Thank you for watching. Other questions that you might want to see from this paper can be found in the playlist that will appear in this area over here. Other questions from M1 vectors in general can be found in the playlist that will appear over here. And you can subscribe to my channel by clicking on this link. Don't forget to look at the description of the videos to see my links to other papers, like the other units, P1, P2, P3, P4, S1s, for example, and also some of my IGCSE work from that I've made. So you're welcome to have a look at that. Thank you for watching, and see you soon.